Hi, my name is John Wilson with MDS. In this video, I'm going to cover how to set up a test of an assembled motor using the peak-to-peak error area ratio. So in our previous videos, we set up resistance test, megohm test, and a surge comparison test. Of course, a surge comparison test is ideal for testing a stator, a stator without the motor, or rotor. When we do have the rotor installed, we really can't use the surge comparison test because of coupling of the rotor. So what we do in that case is we set up a special surge test using the peak-to-peak error area ratio. Some people also call that the pulse-to-pulse error area ratio as a way to identify shifts in the waveform that are indications of arcing turn-to-turn faults. So to set up this test, the easiest thing to do is, of course, make a copy of an existing step. Now, the surge test is different than the resistance and megohm tests because you really can't do the copy in this screen like you see right now. It's blanked out. What you have to do is edit that step, get into the surge setup screen, and select the button that says Test Steps. Now we can make a copy and we'll insert it right away. Then we'll edit this one and we'll change the way it behaves. First thing we're going to do is take it out of comparison mode. 1 to 2 is fine. And I will do change the name to match what we're doing here. I do like to make these names descriptive of what we're doing, just so I understand from just looking at the test plan what's going on. So I'm going to set up the peak-to-peak test. I'm going to automatically control the voltage, and that's all we have to do to this screen. And in this case, we've got EAR set to 10%. That's a pretty good value or number for the peak-to-peak error area ratio. We start at 500 volts, go to 2000 volts, but we don't want to go in one step. We want to make this about 25 volts per step. And I think that looks pretty good. Let's run it to see how well it works. So again, we're going to start at 500 volts and increase the voltage in 25 volt steps as we go up. Now you can see in the light tan color here, that's the peak-to-peak error area ratio. You can see that in the video here, between pulses occasionally you can see a red area there. That is the area in between the two waveforms that we are going to use in our EAR calculation. Now if we had a turn-to-turn arcing fault, we would see the EAR value jump up way high, like 50% or maybe even 100%. And that's the indication of an arcing turn-to-turn fault. So again, in this case, we're going to use the EAR as an algorithm to look for a arcing turn-to-turn fault. We're not going to use the EAR to compare phases to each other, because in an assembled motor, the differential rotor coupling won't let us. We'll always get different waveforms if we have a rotor installed. So here, that worked pretty well. Let's take a look at our test steps. We got 1 to 2. Let's add the other 2 steps, 2 to 1, or 2 to 3, and 3 to 1 for the other 2 phases. So we'll copy this step, we'll insert it, and then we'll insert it again for our 3rd step. Then we'll edit this step and change the test leads. So one of the very powerful things about the Schleich MTC-2 is that you can program it in any way you want. Now, you don't have to do this programming that we're doing right now every time, but oftentimes you just make a copy of a good sequence, tailor it to the specific motor you're testing, and you're done. Let's see, everything there looks good. Let's take a look at our other last test step. And we will look look at its connections. We want to go 3 to 1. Now that all looks good. So again, we've got a comparison test or a peak-to-peak EAR test that we're going to be looking at. Let's say OK here. Go back to our screen and take a look. And you can see that we've got our surge test and our EAR test all lined up. Now again, we can rerun a specific test or a group of tests just by selecting them, just like you would multiple select a file in Windows Explorer, and then just say we want to repeat those tests. So let's do that. We will save the changes we've made as we added more steps. First, we'll do a surge comparison test, which we really don't have to do since we're doing the peak-to-peak EAR test. Again, this is a stator that I'm testing, so we won't see the differential rotor coupling, but we'll see how the peak-to-peak EAR test works. Since the computer is looking at the waveforms, there's no need for the operator to see the waveform. The computer is using the peak-to-peak EAR algorithm to identify the changes. So the only thing we see here is the EAR graph. Of course, if there's a failure, there'll be a shift in the waveform, and it will jump very high, the EAR value that is. So we're doing lead 1 to 2 in this example, or in this step. Once it finishes, we'll do 2 to 3, and then finally 3 to 1. So you can see we finished 1 to 2 surge test. Now we're going to go on to 2 to 3 and test the other phase connections, that is, the other phase connections. And again, we start out at a low voltage and go up. Now, this particular stator is a fairly low inductance stator. It's actually a generator. So that first pulse there, we might have thought we applied 500 volts to it. But due to the very low inductance, it never got to 500 volts on the terminals of the winding. There we go. Up it goes in voltage. So here we've got our 3 tests set up, and I notice I've got a problem. On the first peak-to-peak EAR test, if we take a look at it, we can come down here and see that we are automatically controlling the voltage regulation. And that is what we want to do. Now on the other steps, let's go check them real quick. And check its connections. And we see that we need to also check the button here that says automatic voltage regulation. And let's do that for the final step. And again, turn on automatic voltage regulation. Now what this is really doing is that even though the MTC-2 itself might be charging up to say 500 volts to apply a 500 volt surge test, the low impedance of some windings will make it so that the actual voltage you get across the windings is no longer 500 volts. It may be, say, 400 volts. By checking this button, we're going to regulate on that actual voltage on the terminals of the stator. So now we have all of those corrected. Okay, as you see, we have all of our surge tests ready to go. I'll press OK and exit. Now let's just run the surge test. Again, we can use this repeat feature to just repeat these specific lines or steps in the test plan and not the others. It's just like multiple selecting files in, say, Windows Explorer. You select the ones you want to repeat, right mouse button click, and select repeat. Then when we press the run button, we will only do the ones we selected. So again, this is a stator only, so we're doing a surge comparison test. The peak-to-peak EAR, of course, is for assembled motors. We'll step right into that one. So first we'll do lead 1 to 2. We'll start out at a low voltage and increase up to 2,000 volts. Now you saw there that the very low inductance of this particular stator kept the voltage down, just a couple hundred volts. Even though internally we were charging up the electronics to 500 volts, the actual voltage that we could create across the terminals of the stator was much lower. So by checking that automatic voltage regulation checkbox, we're going to let the tester look at the actual voltage at the leads of the motor and use that to go through all the way up to our 2,000 volt test voltage. So again, if there was a jump to the left of the waveform, which is the indication of an arcing turn-to-turn fault, we would see a really high jump in the EAR value, much higher than the 10% tolerance that you see on the graph right now. It would jump up very, very high, 50%, 100%. So lead 1 to 2 was done. We'll go through and do 2 to 3 and 3 to 1. Okay, we've done lead 1 to 2, 2 to 3. Now we're about to finish up on lead 3 to 1. Again, we started at 500 volts and wrapping up to 2,000 volts in 25 volt steps. We're about done with the 3 to 1 step here. So far, this stator is holding up very well. It's got good dielectric strength. Nothing is above our 10% criteria there. Everything passes, so we have a good stator here. So that is setting up the peak-to-peak EAR surge test.